In this video, we're going to be taking a look at some simple regression techniques in Python. And there are many tools out there to implement regression in Python, and we're just going to look at a couple of them, specifically what you can do with NumPy. All right, so it's not meant to be an exhaustive tutorial on all the methods of regression in Python, and we're not going to be running any statistical tests. We're just going to be fitting a line, all right, and then visualizing the output of that fit line. All right, so I'm going to make this notebook available on GitHub, and you'll be able to download it from a link in the description of the video. So with that, we can go ahead and get started. The first thing we're going to want to do is set up our environment. And so I'm going to be importing the libraries that I'm going to use. So NumPy, Pandas. All right, we're going to get some live data using the Yahoo Finance API. All right, we're going to visualize things with Matplotlib. All right, and then I'm going to just apply the Seaborn theme to our plots. All right, and we'll use Seaborn at the end. All right, and then I'm going to use date time here to go back a year and get some data. So we'll go ahead and run that cell. All right, next we're going to go out and get our data. Okay, so I'll get data for Google and the S&P 500 ETF. We'll go back about a year. Okay, and then we'll store our data using the Pandas data reader and the Yahoo Finance API. Okay, once we get it, we'll take a quick look at it. Okay, so there it is. All right, we don't actually need all of this data. Okay, so you can see we get a high, low, open, close, and an adjusted close and volume, all right, which you can't really see until I scroll here. All right, all I really need is the close for what we're going to be doing, so I'm going to go back and adjust the data. Okay, so there is our close. All right, and as of this video, it's going back a year in time. Okay, we're not going to be using the closing prices directly, so I'm going to calculate the instantaneous rate of returns for both Google and the S&P 500 ETF. Go ahead and take a look at what we get there. All right, so there they are. We have the first value can't be calculated, so I'm just going to drop that. Okay, and with all that, we are now ready to sort of start looking at regression. I think the first thing that makes sense to do is probably get a correlation here. So I will take our returns, and I'm going to apply the Pandas method core. And we can see that, okay, they're pretty strongly correlated going back, all right? And, you know, since the S&P 500 is a market cap weighted index and Google happens to be very large, it's a question, right, if we're running a regression here to calculate a beta or something like that. The question is Google causing, you know, the S&P 500 to go up, or is S&P 500 causing Google to go up, all right? And so we're not going to try to answer that question. We're just going to go ahead and put S&P 500 as the independent variable here, all right? And then it may make more sense to get a smaller sample. We have about 250 values here. It may make more sense to get a smaller sample so our visualizations are easier to see. So I'm just going to go ahead and sample this. Okay, so I went back and randomly sampled 60 returns, and then we see the correlation's a little bit higher than the overall data set, but I don't think it will make that big of a difference for what we're doing here. Okay, probably the next thing that makes sense to do is to start visualizing this. So what I'm going to do is set a new variable, and again, I'm going to sample our large data frame and get a smaller one. All right, and I'll stick with the 60 data points. It won't be the same 60 data points that was used up here. And then I'm going to go ahead and plot that as a scatter plot. S&P 500 on the X as the predictor or independent variable. All right, and then Google on the Y as the dependent variable. There's our scatter plot, all right, and, you know, we might run some statistical tests to see and make sure that this linear relationship is a good one to model here, all right. The next thing we're ready to do here then is to go ahead and fit our linear model. Okay, so I'm going to set a variable, call it reg, and I'm going to use the NumPy polyfit. Okay, and so this will work for a one variable regression. All right, it doesn't necessarily have to be linear. All right, so the poly indicates that I can use a polynomial here if I want. All right, I'm not going to be doing that. All right, and then I'm going to fit the sample data. All right, and so I'm going to use S&P 500, and I'm going to use it to predict Google. And then I have to indicate the degree of my polynomial. All right, so for a simple regression, the degree is 1. Okay, and then we can see what that output is. All right, so we get essentially the slope and the y-intercept there. All right, so it looks like for every percent that S&P 500 goes up, we can expect Google to go up by almost 1.5%. All right, so this is equivalent to what we predict beta is. Okay, so we can, if we want, plot that against the scatter plot, and I'm going to make a trend line here. And to plot that trend line, I'm going to use the NumPy polyval. All right, and I'm going to pass in the regression, and then I'm going to pass in the independent variable. Okay, so this will make an array with the predicted values based on our best fit line calculated from above. All right, and then I'm just going to go ahead and plot that scatter plot again. Okay, and then I'm going to plot the trend line. Okay, and then, maybe you want to make a different color there so it stands out a little bit. So I'll go ahead and make it red. All right, but there is our best fit line graphed against the sample of data points that we chose from above. Okay, another thing that we often see is regression used as a technical indicator to predict a future price. And so I'm going to put together an example of doing just that. And to do this, I'm going to get some new data, and I'm just going to get it for the S&P 500 this time. Okay, so once again, we just need the closing price, and we're going back a year. And once I get the data, I'm going to regress it essentially against the date. All right, and I'm not going to be able to regress it directly against the date, so I'm going to add a column that serializes time. Okay, we're going to add that column to our data frame. All right, and this is actually going to get me a series, so I'm going to make sure it is saved as a data frame. Okay, I'm going to reorganize my data. Put the time column first, and then the close. And then I'm going to take a look at what we get. All right, I'll look at the last few rows. Okay, so you can see that, we have the serialized time here. We have 253 observations. And you can also see that there's probably a little bit more precision here than we really need. All right, so I'm going to do one more thing before we go ahead and try to fit our linear model. I'm just going to round off. Okay, so with all that done, we're ready to go ahead and fit our model. We're going to do it the same way we did before, except for this time our independent variable is time, all right, or the succession of time here. And then the dependent variable is going to be the S&P 500. Okay, so exactly the same procedure as the first example. And we can go ahead and take a look at the slope and y-intercept here. All right, so we can see that it's predicting that time, right, basically as we progress, we should move up a half. Okay, so once again, right, we get our slope and our y-intercept. Okay, so once we have our model fit, I'm going to pretty much proceed the same way. Right? I'm going to first make an array that stores the predicted values in it. All right, and I'm going to again use MP polyval here. All right, we're going to pass in the regression coefficients, and then we're going to take a look at the time as predictor. All right, and I'm only going to go back the last 3 months or last quarter. All right, so we're not going to fit the line to the entire series. We're just going to see it out at the end of the data set. And then in addition to this trend line, I am going to sort of plot a channel where we move plus and minus 1 standard deviation away from that linear model. Set a variable here. We'll look at the data and then the close, and once again for the last quarter. All right, and then we'll get the standard deviation. Once we're done with that, we can start building our plot. So I'll just start by plotting the actual data against time here. Okay, I'll add a label in case I want to put the legend on there. Take a look at that. All right, so there's what we have so far. All right, we can see it's a very strong uptrend in the last year. Okay, I'm going to make the plot a little bit bigger here. So, all right, and then we're ready to go ahead and start adding on our trend lines. All right, so. Okay, so there it is for the last quarter. And then, right, to get our channel here, I will just duplicate this. All right, and then, we can decide what color to plot it in. I'll just do green, I guess, and then we'll do 1 minus the standard deviation and 1 plus the standard deviation. Okay, so there you have it. And, depending on what you're doing, you can fiddle around a little bit and get something closer to what you might see in some of the technical analysis packages out there. All right, but generally, right, we fit the model and then, right, plot some kind of channel around that model. One other thing you can do with the linear model is make predictions about the future, right? And that might be most useful here, where we're just looking at this strong upward trend and we have time as our indicator. And if time is the main predictor here about price, we can sort of extend out further into the future and see what it predicts. All right, so I'm going to set a variable, call it predict. And for this, I'm going to use another NumPy function, and it's the poly1D, all right, one-dimensional. I'm going to pass in the regression, and essentially I get returned an object based on that regression, and then from there I can just plug in a value. So if I want to know, we ended at day 253, if I want to know what we predict for day 254, it's saying 429, all right, and essentially 26, all right, and then, plus or minus that 1 standard deviation. All right, if we want to go out further in time, say to day 300, we can see that it's predicting this thing is going to be around 450. Okay. All right. And then finally, if you just want to see a scatter plot with a trend line on it, you don't want to worry about how do I do that with NumPy. All right. Seaborn has several built-in plotting methods that will help you get there. All right. And I'm just going to show one of them. All right. I think there's about 4 or 5 different ones. All right. But I think the one that makes the most sense for us is this reg plot, regression plot. All right. We're going to tell it that, again, the x-axis is time as the predictor, and then, right, the y is close. Okay, and then I'm going to ask it to fit the regression. All right, and if you just want to see it for the last 3 months again, right, we'll pass in the same way we did up above. Okay. Okay, so there is just our trend line. Now, what we don't get is, the ability to sort of use that slope and y-intercept, all right? And then you can see sort of this pale channel around the prediction, right? And it gets thinner in towards the middle. All right, so that's the confidence interval of the prediction. And if you don't want to see that, if you just want the trend line, right, we can ask it to leave off the confidence interval. Okay, so I hope that helps you get started using linear regression with Python.